Another property of gases is that they can be squashed or compressed. Compress the air inside this sealed syringe, let go, and the air expands, pushing the syringe back up. In a gas, the particles are spread out. It's easy to squash them closer together. But release the pressure and the particles immediately move as far apart as possible, pushing against the syringe. Compressed gases can act a bit like springs. This awesome ride at Blackpool Pleasure Beach uses compressed air to catapult its riders to a height of 65 metres in just 2 seconds. As soon as the passengers have been safely harnessed in their seats, their combined weight is measured. It's like a big set of scales. The greater the weight, the more compressed air it takes to launch the riders to the top of the tower. The air is forced into a tank and held under pressure, and then it's ready to go. Other fairground rides use compressed air too. The braking systems of many rides rely on air to stop the cars. You can hear the hiss as the compressed gas escapes. Under normal conditions, gases take up a lot of space. During the Second World War, some cars were converted from running on petrol to running on gas, carried in huge bags on the roof. But it's difficult to carry large quantities of gas like this from one place to another, and let's face it, it looks stupid. Today, gases are transported in high-pressure cylinders. The equivalent volume of 300 cylinders of normal gas can be forced into just one by compressing it. So the cylinders need to be extremely strong. All sorts of gases are stored and transported in this way. Different gases have different uses. Carbon dioxide gas is used to put the fizz into fizzy pop. But how did it get there, and just how much gas is there in a bottle of pop? The gas arrives at the pop factory in huge tankers as liquid carbon dioxide. When CO2 is cooled and compressed, it liquefies and takes up less space. So, 700 tankers worth of gas can fit into just this one. In a totally different part of the factory, the cola drink is being prepared. All the ingredients are mixed together in huge vats. The liquid carbon dioxide is transported around the factory through a network of pipes. It's heated up, turned into a gas, and injected into the flat cola mixture. The bottles are filled and capped immediately to keep the fizz in. Because gases are so compressible, it's possible to squash the equivalent of 8 litres of carbon dioxide gas into this 2-litre bottle of pop. This factory produces 1,500 cans of pop and 250 bottles every minute, so you're talking about a lot of fizz. Just think how much carbon dioxide is trapped in all these.